2 with learning about atoms in the periodic table. And to do that, the first thing we need to do is we need to learn about the atoms. We need to learn about the parts of the atom, and we need to learn where they're located and what their charge is, and how we can figure that out if we don't know one of the three. All right, so here I have my atom. This is a blank atom. I've got a center that's called the nucleus, and I have an outside shell. These can be called valence electron shells on the outside, or we can call them energy levels. We also call that the electron cloud, okay? But first, we need to know where things go. So we know that our neutrons are going to be located in the nucleus of the atom with a mass of 1 AMU, and they have no charge. So when I take a neutron and I drag it to the center, okay, if I have one neutron, it stays right there. All right. Also, our protons are located in the nucleus. They also have a weight of 1 AMU, and they have a charge of plus. So this is going to be a positive charge. Protons are positive. So I'm also going to drag one proton to the nucleus to sit here with my neutron. You'll notice this simulation has already called this hydrogen, and we'll learn why one proton and one neutron is hydrogen. All right, the last particle is the electron, and it is not in the nucleus, it's in the electron cloud. And electrons are so tiny and so fast, they don't weigh anything, so we give them no weight, and they have a negative charge. Okay, so if I drag my electron to the outside, I have one electron. Okay, my electrons are negative, my protons are positive, and my neutrons are neutral. So now I have a positive and a negative, one of each. So I am neutral. All right, now we're going to go down, and you're going to see this is the Bohr model, and it says it's a carbon atom. That means it must have something about this atom that makes it carbon, and we'll see what that is in a minute. In the center, it's hard to see, but we're pointing to our neutrons right here that have no charge. This is pointing to our other part in the middle, which we know are our protons. And then we have our electrons on the outside shell. Okay, so this is actually pointing to the shell, so this is our electron cloud. And these are the little electrons. And we know these have a negative charge, protons have a positive charge, and neutrons have no charge. But this is pointing to the outside shell. We always call the outside shell the valence shell because our valence electron goes there, and valence just means outside. All right? Now, if we look at an actual element, all right, we know that on the periodic table, it is made up of several elements. Now, you have a blank one that needs to look exactly like this. Now, the colors don't have to be the same. However, the words and the way that it's colored does need to be the same. But we're going to look at beryllium. On this side of the paper, we've got beryllium. Now, you can see beryllium is atomic number 4, and it's right here. And everything looks exactly the same as it does on my paper. So there's a couple things these numbers can tell us. The number of protons never changes in an atom. It never changes. It is the atom's identity. And if you ever change the number of protons, you'll change the element. For example, beryllium has an atomic number 4, meaning it has 4 protons. Magnesium has an atomic number 12, meaning it has 12 protons. That is always the same for each atom. So beryllium will always have an atomic number of 4. And remember, the atomic number is like its DNA. So this is exactly how many protons it will have. Okay, in the middle part, that tells us the symbol for the element. Then we have the actual element name. And at the bottom, we have the mass of the atom, the atomic mass. This atomic mass tells us how much the atom weighs. Now, you'll remember, protons and neutrons are the only two parts of the element that have weight. So this is the total of our protons and neutrons, and this is just our protons. So we're going to write that at the bottom. So if we're looking at neutrons, neutrons are neutral, and we know that we can find them by doing atomic mass minus atomic number. All right, so in the case of beryllium, the atomic mass was 9.01 minus the atomic number, which was 4, and that gave us 5 neutrons. So we have our atomic number, our atomic mass, and that gave us 5 neutrons. All right, so how do we find the protons? All right, we want to find the protons. This one's very easy. It's just the atomic mass. I'm sorry, the atomic number. So in beryllium's case, the atomic number we saw at the top was 4. So there are 4 protons in beryllium. Okay? And then for the electrons, we can find the electrons because we know that this is negative and this is positive. So we want those two to be equal. So in a neutral atom, it's the same as the atomic number if we want them to be equal. So we can find the electrons by finding the atomic number. So it's going to be the same as the number of protons in a neutral atom. Okay, so now let's look at some examples of these. I'll put this over to the back, the next page. We have carbon at the top. We know what our atomic number is. We know what our symbol is. We know what the name is. And we know that if we take our mass, subtract out the protons, we can get the neutrons. So we're not going to worry about drawing the Bohr model right now. That's just the model of the atom. But we are going to look at what should go here. So for sodium, my atomic number is 11. The name is sodium. And the atomic mass is 22.9. So I could round that up to 23 if I wanted to. So I know my protons is the same as my atomic number. Electrons is going to be the same as my atomic number. And for neutrons, I'm going to take 23 minus 11. That is going to be 12. Okay, now for aluminum, if I want to find aluminum, Al, I'll notice that it's right here. Aluminum has an atomic number of 13. That means I have 13 protons and 13 electrons. The name is aluminum. And its atomic mass is 26.9, which I could round to 27. So 27 minus 13 is going to be 14. All right, now let's look at this one. It says 7. So I need to find atomic number 7, and I see it right here. That number never changes, so that should be N. It's going to be nitrogen. and the atomic mass is 14. So my protons are 7, my electrons are 7, and 14 minus 7 gives me the neutrons, which is also 7. All right, down here at the bottom, silicon. I know the symbol is Si. I need to find it. It's right here. It's got an atomic number of 14 and an atomic mass of 28.0. Okay, so my protons are 14, my electrons are 14, and my neutrons are 14. 28 minus 14. All right, now I'm looking at number 2. I see 2 right here. It is helium, He, helium. It has an atomic mass of 4.0. My protons, right here, my atomic number. And then 4 minus 2 is 2. All right, and the last one is argon. Argon is right here. We've got an atomic number of 18. The name is argon. And 39.9 or 40 is my atomic mass. So I've got 18 protons, 18 electrons, and 40 minus 18 is going to be 22 neutrons. All right, so just to show you what the Bohr model would look like, if we had helium, okay, we would have a nucleus with 2 protons and 2 neutrons. So I'd have 2 protons, 2 neutrons, and then I would have 2 electrons sitting on the outside shell. Okay? All right. So that is all for the notes. Next, we are going to look at the periodic table. All right, so here is your copy of the periodic table. You'll notice there are some lines here that we need to label, and we're also going to color it so that you'll be able to see the distinct sections of the periodic table, and we'll understand better later why they are that way. So the first thing I want you to do is you'll be able to print this off and make your periodic table look exactly like this one. All right, so the first thing on the periodic table is that the up and down parts of the periodic table. So the vertical columns are called groups. Okay, the groups of the periodic table are very important. We group everything that is alike in a vertical column. They behave similarly. For example, this group 18, they all do not react with other elements. Group 1, you'll notice a little 1 above it, they all react very violently. Okay, group 17 also reacts violently. The transition metals in the middle, we kind of bulk them together and skip them because they don't react with much of anything. All right, so what I want you to do is make sure that your blank periodic table looks like this. The colors do not have to be the same. However, we need the lines labeled and we need them colored according to the way this is colored. So for example, group 18 from number 2 down to number 86 all need to see the same color. Everything to the right of the darkened staircase needs to be one color. These are your non-metals. You'll notice there's a balloon on here that means they are a gas, and it tells you that down here at the bottom. And then your liquid at room temperature is bromine. Everything inside the darkened staircase is going to be your metalloids. They have some properties of metals and some properties of non-metals. They're right in the middle. And then everything to the left of the staircase back to group 3 is going to be your transition metals. Okay, all of them. We leave these off just because we are not very sure about how they react. So just be sure you leave those white. 113 through 118 we are going to leave white. There's the most recently discovered elements. Then we have group 2. That needs to be its own color. This column right here. It can be any color, but it needs to be its own color. And then notice, number 1, hydrogen, you are going to leave blank. It is not going to be included in the way you color group 1. The reason is, group 1, these are all metals, but hydrogen is not. We'll learn later that hydrogen is there because of its valence electrons. However, it is a gas, so I don't want you to include it in the alkali metal group. I want you to leave that white. All right, so be sure you have gotten these written down. Your alkali metals, your alkaline earth metals, the transition metals, the metalloids, the noble gases here in group 18, the halogens in group 17, and then all of this section is your non-metals. Now, these little things right here are our charges. We can also call them oxidation numbers. They're going to tell us how well and how many electrons certain elements are going to gain or lose if they are bonding with another element. We just said that the vertical columns are called groups. The horizontal rows, as you'll see right here, are called periods. Okay, P-E-R-I-O-D-S. So we have the lanthanide period and the actinide period. Okay, so be sure you have periods and groups labeled on there.